In December 1961, the Swedish government gave its approval for the development of aircraft System 37, which would ultimately become the Viggen. By 1962, all elements for the project either existed or were close to fully developed. These included the aircraft itself, the power plant, ejector seat, armaments, reconnaissance systems, ground servicing equipment, and training equipment such as simulators. In February 1962, approval of that overall configuration was given and was followed by a development contract in October 1962, according to aviation authors Bill Gunston and Peter Gilchrist. The project was by far the largest industrial development task ever attempted in Sweden. During the 1960s, the Viggen accounted for 10% of all Swedish R&D funding. In 1963, Saab finalized the aerodynamic design of the aircraft. The aerodynamic configuration was radical. It combined an aft-mounted double delta wing with a small, high-set canard foreplane, equipped with powered trailing flaps mounted ahead of and slightly above the main wing. This would be judged to be the best means to satisfy the conflicting demands for STOL performances: supersonic speed, low turbulence sensitivity at low-level flight, and efficient lift for subsonic flight. Canard aircraft have since become common in fighter aircraft, notably with the Eurofighter Typhoon, Das Ultrafale, Saab aj37 Gripen and the Tiger, but principally for the purposes of providing agility during flight rather than for its STOL capabilities. Further aerodynamic refinements during the later stage of development included the addition of dog-tooth patterns upon the main wing to generate vortices, allowing for their elimination of blown flaps. From the canard, the use of a thrust reverser enabled the sought short landing performance. During development, Saab had opted to power the type using a single large turbofan engine. Originally, the British Rolls-Royce Medway engine had been selected to power the Viggen. However, development of the Medway engine was cancelled due to the intended launch aircraft. Saab chose to adopt a licensed production version of the American Pratt & Whitney JT8D engine, the Volvo RM8, instead. The RM8 was heavily redesigned, using new materials to accommodate flight at Mach 2 speeds, a Swedish-built afterburner, and a fully variable nozzle.